Hello all, welcome to my channel. So today I would be starting with characteristic of transistors. So it can be in three different configurations, but I would be talking about only two, that is common base and common emitter, not about common collector. You can do that yourself after you will learn the common base and the common emitter. So the common base, in this case we have a NPN transistor here. I have chosen a NPN transistor. So the arrowhead will be in this direction. That means the current of IB will be in the upward direction. Now, in this case, the input in this case will be VEB as applied in the junction of forward bias. So this is my input and we would be measuring the current IE in milliampere it will be. And now let's start with the topic. So in this case we have to study about the input resistance and the output resistance. So if we want to measure resistance, we need current and we need voltage. So in this we would be giving the voltage of VEB. That means it will be our input. So we will be applying voltage VEB to emitter and the base. And remember, whenever we are talking about common base, that means your base will be earthed or grounded. It will be grounded. Whatever you be taking common, that would be grounded. Now in this case we would be applying the input to VEB. So that will be our input. Now one thing you have to remember, that you have to keep VCB as constant. And we have here two batteries, that is VEE, negative positive and positive negative. Why positive here is because the first one should be a forward bias. Why positive negative here? Because when N is connected to a positive, that means it is reverse bias. So this is forward bias, this is reverse bias. Now in this case we would be applying VEB as our input and we would be getting the current as IE in this case. When we are taking common base, we will get current as IE, and in this case remember that VCB is a constant. So this can give us the input characteristics of this system. If we are taking VCB as constant, that can give us the input characteristics. For input characteristics we require the resistance. That means we want to know what is the resistance in the flow circuit, that is Rin, or you can say AC input resistance in this case. So let us draw the input resistance for say. So for resistance, as you know, we need IE and VEB in this case. So as I earlier told you that you need to keep VCB as constant. So you can change the values, but for single value you should check what is the graph for IE and VEB. So in this case the graph will be like this. This is how the graph is made. But in this case, if you take, suppose you take VCB as 0, so the graph will be steeper. Why? Because it will take time to reach the to have the current in it. But if you take negative value, no negative value of VCB, it will be faster as you are providing it with a negative value. Now if you say minus 20, the slope will get more steeper towards the current. Now in this case VCB is constant. So when VCB is constant, you have IE and VEB. So that gives us the input resistance, input characteristic of a particular circuit. So in this case, you can easily find Rin. Rin means the input resistance, AC input resistance. So that will be del, the change in del VEB over change in del E, and when taken constant VCB. So VCB is taken as constant. So this is the value for Rin, that is del VEB over del E, taking constant VCB. So that will be the input resistance for the common base. Now I will be finding the output characteristic. So when I need to take the output characteristic, I would be measuring IC and would be taking taking constant IE. So IE will be constant and we will get IC and we will get VCB here. IE will be constant for the output resistance and we would be counting IC and VCB to get our output. So let us find output resistance. So IE will be constant here now. The input part will be constant here now. So the graph look like this. VCB here, the output voltage and output current IC. In this case, we will be taking IE constant. So taking IE constant, let us suppose that first IE is 0 milliampere. So it actually starts from the negative current and initially goes to the positive voltage. Similarly, as you increase VCB IE value, there will be increase in the IC value. So that's how the graph looks like. So in this case, suppose IE is 0, IE is 5 and so on. So in this case, my R output will be del VCB, change in voltage of collector base, and del IC at constant IE. So that's how we will get our output characteristic. So that's about common base. So that's the end for common base transistor characteristic. Now I will continue with common emitter characteristic. Hello all, welcome to my channel. So I will be continuing with the topic common emitter characteristics of the transistor. So in this case, we need to study again the input characteristics, the output characteristics. So the purpose is same, the phenomenon is same, everything is same. So in this case, we would be taking VEB as input and IB as output. In this case, because we need to study the input characteristics first, so we would be keeping VCE as constant. We can take it any value. We can take 1, 2 or 3, anything we can take. Then only we can find what is the resistance in the input circuit. So let us find this. So in this case, we would be taking VEB. Let us find the input characteristics. So VEB and with respect to IB, that is in microampere. And we are keeping constant VCE. So this will be constant and we can change the particular value for different. Now as you increase the VCE, if you increase the VCE, there will be change in the IB, correct? So as you increase VCE, there will be increase in the IB value and the graph will shift to right of the VCE value, initial value. So let's see how the characteristic will look like. So suppose my VCE at 2 volt, it is like this. Now if you increase the VCE value, it will increase towards the right hand side. So if you increase further, it will increase further. So what will be Rin in this case will be, we have to change with respect to VEB over del IB at constant VCE. This is nothing but the wherever the graph will have a steeper line, we can easily find the slope of the graph. So this is nothing but a slope of the graph. So you can easily find Rn with the help of a graph. So let's talk about output characteristics now. So when we talk about output characteristics, we need to measure for this part of the circuit, the second part of the circuit. That means we would be taking VCE value and keeping constant IB in this case, and IC will be on the y-axis. That means IC is changing. So let's find how to make output characteristic. We would be keeping IB constant in here. IB is we would be taking IC value because it is on the second part, and we would be changing with respect to VCE and keeping IB constant. So if IB is constant, it will increase like this. There is some increase, then a steeper line. There is some increase, then a steeper line as soon as you increase the current. So if IB is 0, it will have less current. If IB is increased by some value, so it will increase. Similarly for the third one. Now if you want to find R out, that means resistance output, then you have to take change in VCE over change in IC at constant IB. So this is how you will find the R out value. So that's about common emitter characteristic. So in the next class we will learn about amplifiers, how amplifiers are made up of common emitter and how they are useful to us.